Hello students, today we are going to learn about energy quantization, energy levels in an atom, and how scientists explain the structure of the atom. In 1910, Ernest Rutherford showed that an atom is made up of a heavy positively charged center called the nucleus. Around the nucleus are tiny negatively charged particles called electrons moving around the nucleus. However, there was a problem with Rutherford's model. Because of the attractive force between the nucleus and the electrons, scientists believe the electrons should gradually lose energy and spiral into the nucleus. If that happened, atoms would collapse. But atoms are stable, so another explanation was needed. In 1913, Niels Bohr solved this problem by applying quantum theory to the atom. Bohr suggested that electrons move around the nucleus in spatial paths called orbits or energy levels. While moving in this fixed orbit, electrons do not lose energy. Electrons can only gain or lose energy in small definite amounts called quanta. Therefore, electrons exist in specific energy states known as quantized energy levels. This idea was supported experimentally by Max Planck in 1902. Planck explained that energy is not released continuously. Instead, energy is released in tiny packets called quanta. The energy E of radiation is given by E is equal to hf, where n is equal to 1, 2, 3, and E is energy of the photon, h Planck constant, f frequency of the radiation. This means that energy is emitted in fixed amounts that is quantized, not continuously. For example, if the fixed amount of energy is 3 joules, the energy emitted will be in multiple of 3 joules, such as 6 joules, 9 joules, 12 joules, and so on. Energy levels in atoms. Electrons in an atom are arranged around the nucleus in position called energy levels or electron shells. These energy levels are usually represented by straight horizontal lines. Electrons in the orbit closest to the nucleus have the lowest energy because they are strongly attracted to the nucleus. Therefore, it takes more energy to remove electrons from the first energy level than from any other higher energy levels. The energy of an electron in a particular orbit n is given by En is equal to minus 13.6 divided by n squared electron volt, or E is equal to minus 1 divided by n squared R, where En is the energy of the electron, n principal energy level or shell. 13.6 electron volt is the ionization energy of hydrogen atom. R is a constant, the Rydberg energy constant for hydrogen. The negative sign shows that work must be done on the electron to remove it from the atom. Electrons in higher energy levels are less tightly held and are easier to remove. Why the difference? In the first equation, R is equal to 13.6 electron volts. If we substitute R is equal to 13.6 electron volts into equation 1, we get E is equal to minus 13.6 divided by n squared electron volt, which is exactly the second formula. The only difference is that one writes the constant as 13.6 electron volt, while the other uses the symbol R. Sometimes, an electron absorbs energy and moves from a lower energy level to a higher one. When this happens, the atom is said to be in an excited state. However, excited states are unstable. After a short time, the electron returns to its original energy level or a lower energy level and releases energy in the form of light or electromagnetic radiation. The energy released is given by change in energy is equal to En minus E naught, which is equal to HFN, also equal to Hc over lambda, where change in energy dE is equal to change in energy. En higher energy level, E naught lower energy level, H Planck constant, F frequency of emitted radiation, lambda wavelength. The energy needed to move an atom from ground state to excited state is called excitation energy. E is equal to EV, where V is the excitation potential. If enough energy is supplied, an electron can completely leave the atom. This process is called ionization. The energy required to excite the atom from the ground state to the nth level is given by An is equal to 13.6 bracket open 1 minus 1 divided by n squared bracket close. In summary, Ernest Rutherford discovered that atoms contain central nucleus. Niels Bohr explained that electrons move in fixed energy levels. Max Planck showed that energy is emitted in small packets called quanta. Electrons absorb energy to move to higher levels and emit energy when they return to lower levels. The amount of energy emitted or absorbed by a body is an integral multiple of a constant quantity called energy quantization. Thank you for watching. Don't forget to like, share, and subscribe for more physics lessons to encourage us. See you in the next lesson.